Hello students, welcome to online session. We were doing the second chapter, rational numbers. So in the previous session we have learnt about what is the definition of rational number and the closure property. Now we will do commutative property. Okay, it is also called commutativity. So what is commutative property? Take any number, say a and b, and add these numbers and check whether if you add the other way, that is b plus a will also give you the same answer. If it gives the same answer, then we can say commutative property holds good under addition, because we are doing addition here. Then the same way with subtraction, we have to check whether it is, like for example, a minus b is equal to b minus a. If this condition satisfies, then we can say it holds good for subtraction also. The same way with multiplication, a into b gives you b into a. Then division, a divided by b is equal to b divided by a. Then if this condition holds good, then we can say commutative property holds good for under division for these numbers. Now one by one we will check. Okay. Now first natural numbers. So let's see for natural numbers. Example, let me take 5. 5 plus 3 is equal to 3 plus 5. So what is 5 plus 3? It is 8. Here what is 3 plus 5? That is also 8. So these two are equal. We can say that commutative property holds good for under addition for natural numbers. Now coming to subtraction. Shall we take the same example? 5 minus 3. Okay, what is, and then 3 minus 5. This should be the condition. What is 5 minus 3? It is 2. What is 3 minus 5? It is minus 2. Is this 2 equal? No, it is not equal. 2 is not equal to minus 2. So this condition doesn't hold good. So we have to say, we can say commutative property doesn't hold good under subtraction for natural numbers. Okay. So when you change the order, it should be equal. So now let's see for multiplication. When you change the order of the numbers, whether these two will be equal or not. So the same examples I'm considering. 5 into 3 is equal to 3 into 5. So what is 5 3s are 15. What is 3 5s are? That is also 15. So I can say that this property, commutative property, holds good under multiplication for natural numbers. Now coming to division. 5 divided by 3 is equal to 3 divided by 5. This is not equal to this. 5 divided by 3 is not equal to 3 divided by 5. You will get different answers. This is a improper fraction and this is a proper fraction. Here itself you can make out that these two are not equal. So here this condition does not hold good. So I can say commutativity doesn't hold good under division for natural numbers. And it is the same thing with whole numbers also. Okay, because the difference between natural number and whole number is just a 0. Here you have 0, here you don't have a 0. So I can just write it. You can check it on your own with some examples. Fine. Now coming to integers. 1 second. Okay, now we'll check with for integers. Okay, I have taken two numbers, minus 7 and 8. Both are integers. One negative number and one positive number. Now when I add these two numbers, I will get minus 7 plus 8 is 1. Right? And then 8 minus 7 is 1. So when I interchanged these two, the answer did not change. Here also I got 1 as the answer. Here also I got 1, which is nothing but, both are equal. So I can say that commutative property holds good under addition for integers. Now coming to the same numbers I have taken for subtraction also. Minus 7, instead of plus sign I have written minus sign here. Okay, remember this minus sign here, the same way. Minus 7 minus 8 gives you minus 15. And here, so 8 minus into minus plus, it becomes 8 plus 7, that is 15. So is this equal? No, it's not equal. Minus 15 is not equal to 15. So commutative property doesn't hold good for under subtraction for integers. Okay. Now coming to multiplication. The same numbers are taken. Minus 7 into 8 is minus 56. And then 8 into minus 7 is again minus 56. Now when you change the order of multiplication, order of the numbers in the multiplication, the answer did not change. It is the same. Here also minus 56, here also minus 56. So I can say that commutative property holds good under multiplication for integers. Now coming to division. Is this equal, children? By just looking at this, minus 7 by 8 is not equal to 8 by minus 7. Okay, it can be in the denominator, or if it is in the denominator minus sign, it is as good as writing in the. Okay, so this is not equal, so I can say that commutative property doesn't hold good under division for integers. Okay, now we will see for rational numbers. As you can see in these examples, I have taken rational number 1 by 2 plus 2 by 3. Okay, when I interchange this, what will be the answer? Let's see. What is 1 by 2 plus 2 by 3? It is 7 by 6. The LCM is 6. So the answer is 7 by 6. The same way, 2 by 3 plus 1 by 2 is also 7 by 6. So I can say that the commutative property holds good under addition for rational numbers. Okay, now let's take this example for subtraction. 1 by 2 minus 2 by 3 is same as 2 by 3 minus 1 by 2 or not? We'll check. Okay, 1 by 2 minus 2 by 3 is minus 1 by 6. Whereas in this case, 2 by 3 minus 1 by 2 gives you 1 by 6, which is not equal. So this property, that is commutative property, doesn't hold good under subtraction for rational numbers. Now coming to multiplication. So when I multiply these two rational numbers, I get 1 by 2 into 2 by 3, I get the answer 1 by 3. Now again I interchanged the numbers. 2 by 3 into 1 by 2 gives you the same answer. Here also 1 by 3, here also 1 by 3, which is equal. So here I can say that commutative property holds good under multiplication for rational numbers. Now coming to division. So 1 by 2 divided by 2 by 3. So what do we do for division? We have to take the reciprocal of the divisor. So 1 by 2 as it is I wrote, 2 by 3 becomes 3 by 2, and multiply these two, you will get 3 by 4 as the answer. Do you get the same answer when you interchange the numbers? That is 2 by 3 divided by 1 by 2. So 2 by 3 write down as it is. What is the reciprocal of 1 by 2? It is 2 by 1. So the answer you get is 4 by 3. So 3 by 4 and 4 by 3 are not equal. They are not equal. So this property doesn't hold good under division for rational numbers. So hope you have understood this much, children. Now moving on to the next property, associative property. So what is associative property now? Take any number, three numbers, A, B and C. First add A and B, and then to this you add C, and check whether this is the same as adding B plus C first and then adding that to A. This is for addition. So basically what is associativity? It is grouping of numbers. First in this case I added A plus B, and then for this sum I added C. But in this case I added B plus C and then A. So if this condition holds good, then we can say its associative holds good under addition under these numbers. I've already written I want you people to check whether this condition holds good using the examples. Okay, I'm not going to give you the example like how I gave for commutative and closure property. This is for you to do it on your own. Okay children, take some examples, find out whether this condition holds good, and then do it accordingly and check whether these whatever I've written is correct or not. All the tick ones means it holds good for that operation, that particular operation. For example, in subtraction I've written all into marks, that is it doesn't hold good for under subtraction for these numbers. Okay, only thing is you have to change the operation sign over here. So this is for addition. So for subtraction, instead of plus you write minus over here. Understood? The same way for multiplication, instead of plus you write multiplication and find out using the example. Some examples you take, some numbers. So now you know what is a natural number, whole number, integers. So take some examples from those and find out whether this condition holds good and this table is correct or not.